The purpose is to deploy an application on CI/CD pipeline using Jenkins as a tool. But first, we will use Terraform to provision the infrastructure in AWS, our Kubernetes cluster, a master node, and 2 worker nodes in AWS cloud. That's one. Second, we would use Ansible to install Kubernetes and configure the cluster respectively as required. That's with the help of Ansible, a tool we will use for the configuration management of our cluster. Then we use Jenkins from end to end with all the necessary tools, Git, Maven, SonarQube, Nexus, and finally using Docker to create the image and push to Docker Hub registry, and then pull the image in our kube-manifest file for our deployment to be complete. So this is the end-to-end automation process using Jenkins, of course, with associated servers and tools, localhost, which I'll be using to provision the Kubernetes infrastructure. This will configure everything required for the infrastructure to be ready in AWS platform. So on the folder, we'll run Terraform init. That will initialize our backend and install the provider plugins, necessary provider plugins. Having been successfully initialized, we do Terraform validate to validate our code, valid configuration, and we run Terraform plan. We are not likely to get a response for Terraform plan except the AWS key pair, which is called KHS key, which will be created. This is because we want to use a workspace, a Terraform workspace, to execute our task. So what we'll do is the command is we run Terraform. Let's run the command Terraform workspace list to list the workspace or workspaces available at the moment. Right now we have only default, and our Terraform scripts are written to be executed in a specific workspace. So we're going to create that workspace and make it the default or set our tasks to be on that workspace. So we run the Terraform workspace new. The workspace is going to be called AWS_prod. So the workspace is being created and switched to workspace AWS prod. So this is the workspace we're going to be using for the project. Now, if we run Terraform workspace list, we'll have two workspaces now. And if you see the asterisk is on AWS prod, which means this is the workspace we are on now. To confirm that further, you can run Terraform workspace show. It shows you the current workspace you're working with, which is AWS prod. So at this moment, let's run Terraform plan again, and we will see all our resources. The resources to be provisioned will appear. 10 resources to be provisioned, 0 to change and 0 to add. So at this point, we are ready to launch our infrastructure in AWS platform. Yes, cloud platform. And in our Terraform workspace, AWS_prod. So if we run Terraform apply with auto approve flag, we will have our infrastructure being provisioned. At this moment, infrastructures are being provisioned now. So let's take a view at the AWS cloud. So the infrastructure is going to appear here because we set US East 2 to be our default region for this installation or this provisioning of this cluster. So just in a moment, yeah, the Kubernetes cluster is coming up already. Okay, now that our Kubernetes cluster is duly provisioned and checks passed and running, we will now be using Ansible to configure the cluster. The idea is to use Ansible to install Kubernetes and to configure the cluster to properly work using various Ansible playbooks, which we already have here. So the first thing we'll do is to go into our host file. We intend to use the local host file here on the Ansible user. So if we are into hosts, and we have our host here, but we are going to edit these host addresses one after another. And we have fully configured our host file with the master and the worker nodes IP addresses, various IP addresses. I'm using public IP addresses, but if all your infrastructure is in the same network, you're free to use private IP addresses here. And we have the key just there like that. At the moment, we want to make this demonstration as simple as possible. So we need to test the configuration of our hosts. What do? We ping all the servers, all the nodes, Ansible all. We are passing the -i flag for our custom host file that's right here, and then the module is ping. So if we run the ping module, we will see that we have success pinging all nodes, the worker node, worker 1, worker 2, and the master node. So having done that, so we go back and begin to install the tool, the Kubernetes tool in all our nodes. So first thing we need to do after the pinging is to create a kube user. The kube user is supposed to run the Kubernetes commands in the master node. So we run an Ansible playbook, the users.yaml, to run the task. So we run the command Ansible playbook, we're passing the -i flag for hosts, and then users.yaml. So the aim of this is to create a Kubernetes user in the specified okay, so it's supposed to be users.yaml. So we're installing Kubernetes users in all. Right now, they're all done. Kubernetes user has been installed in all the servers of our Kubernetes cluster. So having done that, so we go to the next step, which is to, on the master node, we have to install Kubernetes on all the nodes. The next step is to install Kubernetes on all the nodes, and we're using the playbook install khs.yaml. So this will install Kubernetes in all of the nodes. So the play is ongoing. It's installing containerd config file, containerd Kubernetes networking, applying new settings. So this is going to take a moment, but the process will surely complete to install Kubernetes in all our nodes, both worker node and the master node as much as possible. So this will help us to easily configure Ansible. We're using the tool Ansible here to easily configure nodes to optimize them for service. So the task, the plays are running. So when we're done with that, we will configure the master node. We have another Ansible playbook to configure the master node. The master node to run tasks effectively. So having done that, so the next task we need to do is to configure the master node to be able to run these tasks. But before we configure the master node, we need to do something on this Ansible configuration file. We have an Ansible configuration file, etc ansible.cfg. So if we vi into that, file, the aim is to uncomment line 280 to true. This will enable Ansible user to create the kube-config file. So let's locate line 280. Let's locate line 280 and make sure that is uncommented and true. So here we are at line 280. So allow world readable temp files, which is true. So we're good with that. So we save this file and come. Then we can run the playbook master.yaml. This is intended to configure our master node. Before we go ahead to configure the worker nodes. Don't forget that on the master node, we are supposed to get the token we would use to configure the worker nodes. So that is what is running at the moment. So once we run that and we get the code, everything has been written in the file, with variables. The link to the GitHub account will be there at the description below. So take an advantage of that and get to the detailed description of the whole process that I'm running to be able to configure our Kubernetes architecture to effectively work and deliver for us. So everything has been configured already there. So we have our job done. The code has been created here already. That's the token to join our worker nodes. All right, but we won't be copying it. We have set it so that it will immediately get copied into the temp file we use, from where we'll call forth this as a variable while we configure the worker nodes. So at this point, you may want to confirm that your master node is ready and okay. You may want to confirm that your master node is ready and okay. So let's use EC2 Instance Connect to check that quickly on our web page to check. And while we do that, don't forget that we created a Kubernetes user on this. So we will have to, first of all, switch the kube user. Switch the kube user because it's only the kube user that can run the process. So now we've switched into kube user. So if we do kubectl get node, we'll see the master node is ready. That's it right here. Master node is ready. So control plane master is ready and running. So having confirmed that, we move ahead with the configurations, the rest of the configurations to work. Of course, our worker nodes are not ready. That's why they don't even appear. They've not been configured yet. So we just use the code to join the command created in the previous installation to join worker node. So we run the playbook, Ansible playbook, join workers.yaml. So this is intended to run to join worker nodes to the Kubernetes cluster. This is a self-managed Kubernetes cluster. As you can recall, there are two of them. It can be self-managed, it can be managed Kubernetes cluster where we have EKS, GKS, and so on and so forth. But here we are using a self-managed cluster, which is also, so the task is completed at this moment, and we have our worker nodes fully configured. Now we can also do a check on that and repeat this command here, kubectl get node, and we'll see that all our nodes are ready. The control plane master is ready. The worker nodes are ready right here and right here. 27 seconds ago, they got configured. So now we can continue with the rest of the process. We can continue with the rest of the process. At this point, the next thing to do is to comfortably integrate our cluster with our Jenkins server to be able to deploy applications from end to end. Okay, now that we have successfully configured our Kubernetes cluster, so let's get into using Jenkins to run our respective tasks and deploy the application as required. So the first thing we need to do is to add a new item. Add a new item. Let's call that demo Spring. We're going to be using a Spring Boot application, and it's a pipeline project. We click OK on that. So we go to our pipeline. So this is supposed to be a pipeline. So we start the script, the declarative pipeline script. So the first thing we need to indicate here is agent. So we're using any, agent any. We have tools. We already have Maven installed. So we simply put in tools Maven. We already have that named as Maven 3.9.1. So having specified the tool, we'll go to the first step, the first stage. On the first stage, so we start with the tag stages, curly bracket open. Then we go to stage. So this is the first stage. The first stage, let's call that number 1. And the stage is, of course, it has to be in the bracket. Stage here is the git clone. So we want to clone the repository where this application, the source code is located. So in stage 1, got steps. Okay, so let's get the code cloned. So we get the instruction, the syntax from here. So we're using this, and we go to Git, snippet generator, we go to Git, the URL is right here. We'll copy the URL, paste the URL here. Branch is master. We don't have a credential, so we can add a credential, Jenkins, username and password. So the username, current username is MerciBoi. So in place of the password, we will be getting the token from GitHub account. We'll generate a token for that as our secret, as our password, to be able to configure the credential necessarily. So we've got a token pasted in here. We want to call the ID GitHub thread. Description, you can say it's credential for GitHub. And we add that. So when we add that, we select it here, credential for GitHub, taking it up, and we generate pipeline script for that. So this is the pipeline script for that. So we generate the script, copy that, and go back to our task. Okay, we have a pipeline script right here with agent any tools. Maven 3.9.1 has been installed already, and this is the first stage, git clone, using the credentials we created right from this snippet generator at this point. So we apply this, we save it, and do a build now. Okay, so the first build. So the first build has been done. So that's a git clone, successful. So we can go back in there to configure and take on the next step in the deployment process. So we get back in here to start stage 2. So we get that stage 2 at this point. The stage 2 will be to build, Maven build. So we're using Maven already installed from the global 2 configuration to run a Maven build of application. So stage 2 is on the way. Steps, configure the steps. So we're going to run a simple instruction, mvn clean package. So we run mvn clean to clean any target already there or any of the application already built, and then we'll do package. Package will compile, test, build, and package application as required. So we have the command there, Maven clean package, already stated in our pipeline script. So we apply and we save and do another build. This is for the Maven build, the second stage of our pipeline project. So build is nearing completion. Build is nearing completion. Application is building. Okay, successful build completed. So we go back to our configure and initiate the next step. So the next step, we already have for the next 2 steps for our code quality analysis and pushing our artifact to our Artifactory, our repository in Nexus. We've already configured the server to run. In our Docker Jenkins server, we already pulled Nexus image. So we already pulled Nexus image. So if we do Docker PS, we have 2 containers running right now, which is first one is our Nexus and second is our SonarQube. So from here, you can see that we have our Nexus and SonarQube running as images and containers in our Docker server. You can also have a separate server for Nexus and code quality analysis tool together or separately in a different server. It doesn't really matter, but the most important thing is that in environment, we use, we are heavy on security and good code analysis. So we configure our SonarQube for that, and we configure Nexus to be able to save our Artifactory in case we need to pull them for future use. So right now, so let's build up the script, and they have already been configured. So this is our SonarQube server, this is our Nexus, and the different respective repositories have been created and every configuration done at this point. So let's continue with our build. So we're moving on to the next phase, which is stage 3. Stage 3 is to run code quality analysis, run code quality analysis. So we're using SonarQube to run our code quality analysis. So that's stage 3. Let's configure the steps. So we run steps. So the command here is simply mvn sonar, mvn sonar. So this would automatically run code quality analysis for our artifact already built. Remember, we already built an artifact. It's right there in our workspace. So we've configured the third step, which is to run code quality analysis. So we apply this and we save and we'll build now. So we see the outcome of the third stage. The outcome of the third stage, which is running code quality analysis. Code quality analysis almost done. Almost done. Loading quality profile rules and so on and so forth. So successful. So we've successfully completed our code quality analysis. So you want to see the result? It's going to be right here in our SonarQube server. So we'll go to projects, and this is the result of our code quality analysis. This is the result of our code quality analysis. It's passed. No bugs, no vulnerability, and 7 code smells coverage. Of course, this is a demo application we're using to demonstrate that. So code quality analysis completed and passed. So we go to the next stage. The next stage will be to deploy our artifacts to our Nexus repository. That's stage 4. So we have our step 4 now, where we upload artifacts into Nexus. So here it is. So we apply the script and we save. So let's do a build now. Build 6, which is supposed to upload our artifacts into Nexus. Upload the artifacts into Nexus. So mvn deploy is running now. So successful. So we have our artifacts uploaded into Nexus. Let's take a look at it. So these are Nexus GUI. So in here, let's check our proxy because we configured it to upload. So in our proxy right now, we have our proxy repository all ready for that application and for future applications, all uploaded in here. So let's look into this. So this is our Spring Boot Mongo at the moment. Artifacts have been successfully uploaded into this Nexus repository. So we go on to the next step. And the next step will be to build our Docker image. So we are building our Docker image at this time. So go back to pipeline scripts. We want to build our Docker image. That will be the stage 5. So we run stage 5. That will be build Docker image. Build Docker image. So we do that, specify steps. Specify steps. And in the steps, what are we going to do? We're going to execute Docker build. Okay, the Docker file is already here in the working directory, so we use that. We'll build -t. The image you want to build, let's call it. We'll tag it at the same time. So that's my Docker Hub repository name. I will call that Spring Boot Mongo. Let's give that a version. Let's say version 4. So we're building the image and we're tagging it to this. This is my Docker Hub name, username, and this at this point, I don't need Docker login at this point, but after this point, I'm going to need Docker login, which we will do in a moment. So we apply. So we apply and save and build. Build now. So we're expecting build number 7 to complete stage 5, which is to build Docker image, build and tag Docker image to be pushed into the repository. So that successful image has been successfully built and successfully tagged. Same time, Spring Boot Mongo 4. So at this point, in the next step, I'm going to be doing Docker login. We're going to see how that goes. So the next stage will be, let's call that stage number 6. Docker login is required. Your Jenkins need to log into your Docker Hub so it can successfully push image or images to the Docker Hub repository. So this stage is Docker Hub login. So that's what we intend to do here. So the command so we specify steps as usual, and the command is Docker login -u for username. So my username is Chidinma right there. I'm supposed to pass my password here, and password is password. And because it's not proper to pass my password in a public file like that, because I'm going to save this. So I have to create a credential, a Docker Hub credential containing my password. So how do we do that? Let's apply this at the moment so we don't lose this. So we go to pipeline syntax here. So we want snippet generator. So what are we looking for? With credentials. So we're looking for with credentials. So bindings is going to bind our credentials to variables. So I want to add a credentials because I want to only add my password. So I'm going to choose secret text. So secret text. So the variable is what? Let's call that variable password. Variable is password. Okay, let's call that Docker Hub underscore password. So that's the variable we're going to be calling. So credentials, I don't have any at the moment, so I'm going to add one now. So add. So when we get to kind, we choose secret text. So after choosing secret text, so what's the secret? The secret is supposed to be the password you want to encrypt. So I'm just going to put in my password there right now. So ID is Docker Hub password. Let's call, okay, let's go again. Docker Hub password. Description could be the same thing. Is that there? Docker Hub password. Add. Now that I've added it, so I'm going to choose that right there. So I've added it, Docker Hub password. This is the variable, the way we want to call it in there. And we'll generate a pipeline script for that. So that's it. So that's the pipeline script. So we'll be logging in with this, with credentials, string as this. So we copy that and go back to our pipeline tasks. Go down to pipeline. We're going to paste that after steps. So because we want to use this to log into this, so we're going to paste this right here. So we paste that with credentials. Okay, so we remove this. As a matter of fact, we're going to have this within this. So I'll cut it off from here and paste it here. So let's get this down here. So I'm using these credentials already stated here to log in. So we're not going to hard code this at the moment. So we simply do that, pass that as a variable. And don't forget our variable name is Docker Hub underscore password. So we're not hard coding. So we're not hard coding. So we can move that in here. Okay, so we have a clean pipeline script running. So having done that, so this is the push. So with credentials, string, Docker Hub password, this is variable, Docker Hub underscore password, we've passed it here. So this is going to initiate the login into my Docker Hub repository. I'm going to continue with stage 7 at this time to push. So I go to stage I'm running stage 7 now. Stage 7 is push to Docker Hub registry. Push to Docker Hub registry. Okay. So steps. The command is Docker push. Don't forget we've already done the image as this. So we copy that, paste here, Docker push /Spring Boot Mongo version 4. Let's put it as version 4. So this is pushing to the Docker Hub registry. This would log in and authenticate this action, so it could be done seamlessly. Okay. We're getting to the next step, which is to log in properly. We've seen how we can configure the password, the Docker login password, using the with credentials, and we're going to push. But because we are using a specific image tag here, so each time we run this build is supposed, this pipeline script is supposed to be run at once. So I'm going to change the version here because you cannot build the same version, the same tag every time. So I'm going to change the version here to version 7 so we can comfortably do this build and be able to push it to a repository each time we run this. So that's the idea. So we do build now. We do build now. So the build is going on now. So code quality analysis ongoing. In the real environment, the real production environment, or even test environment, you want to use a pipeline script. It's well edited that you run the script only once, and the process is automated from end to end. So the build is successful at this time. So we've successfully built and tagged and pushed a Docker image to the Docker Hub registry. So let's move on to the next step. After pushing to the Docker Hub registry, we would now deploy the application using a kube-manifest file. And to do that, we will set up the pipeline script to successfully SSH into the Kubernetes master. After the SSH into the Kubernetes master, we will deploy the kube-manifest file. The kube-manifest file has already been written. I will show you that. And the link to get all of these materials is included at the description under this video. So let's get the pipeline script configured for SSH login and deploying the application into our Kubernetes master node. So, but before we continue the next phase, which is to SSH into the master server, there's a plugin we need to install. So let's save this. Let's save this and go to install the plugin. We'll come back to it in a moment. So we'll go back to dashboard, go to manage Jenkins, go to manage plugins, go to available plugins, and search SSH pipeline, SSH pipeline steps. So this is the plugin we need to install for the Jenkins server through this GUI to SSH successfully into the Kubernetes server or any server at all we wanted to SSH into. So Jenkins pipeline steps, which provides SSH facilities such as command execution or file transfer for continuous delivery. So we would install that without restart. So the plugin is completely installed now. So we get back to our job. Demo Spring, and back to our pipeline script. A quick review on our pipeline script. Before we continue, we must confirm that we have this plugin installed. We must confirm that we have this plugin, SSH, installed, SSH plugin. This plugin must be installed and must be fully running. Then we go to Manage Jenkins, Configure System. We need to configure the SSH so that our Jenkins server can SSH successfully into the Kubernetes master node, SSH remote host. So we add host name. Host name is the IP address of our Kubernetes master. So let's get the IP address of our Kubernetes master. We'll paste IP address Kubernetes master on port 22. SSH is port 22. Credentials. We need to add a credential for that. We need to add a password. Username with password. What's the username? Remember, we installed the kube user. So password, we put the password in here. ID is a kube SSH. We can do the same thing here, kube SSH. So that's the credential configured. So we add that kube SSH. So when we do that, leave everything as check connection. So successful connection. So connection here is successful. So we apply and save and get back to our project. So having installed our respective plugins, SSH pipeline plugin and SSH remote server plugin, and configured it, tested the connection, it was successful. So we get back into the pipeline script and we added these. That's our remote server definition before the pipeline syntax began. And let's change this image to image 10. That's what we choose to call it at the moment, image 10. Please note that you can also pass with credentials here for this password. Yes, you can also pass it since it's not advisable to pass a password on an open file in this manner. So image 10 is right there. So this is the stage 7, a quick review from stage 6, where we have the Docker Hub login, credentials, ID, and the command, and the push to Docker Hub registry. We SSH into master. So this, what allows this is because we have SSH pipeline plugin connected. And before you run this script, ensure that your YAML file, springboot.yaml, is in this workspace. Varlib Jenkins, which is the home of Jenkins, which you can do on your command line, and ensure The file is there, workspace. Demo Spring is the name of our project. And this is the file, our kube-manifest file. We are moving this file from this workspace into the remote server. And SSH command remote ensures that our file is applied as required. So we've got that right in here. This is the last stage of the deployment, SSH onto Kubernetes master and deployment. And we want to add and deployment. So this is our last stage. So let's take out every of these and have a clean pipeline script apply. Everything is looking good at this moment. So we can successfully apply the script and we'll have the desired response. So we save and build now. So our final build is running. Our final build is running. And build is still ongoing. So we'll see the outcome of the build in a moment. MVN install running. Build success. Copying the target, building the image and pushing to the repository. Sending file. So the entire script is done. Yes, the entire script is done at this moment. So we can successfully access our application. Yes, since the deployment has started from the beginning to the end-to-end automation process using Jenkins to execute our CI/CD pipeline. So we can access our application. So let's get our server. This is our server IP address. And we want to access that. So our application is exposed on port 31,000. It's a node port. 31,000. So this is our application. This is the application deployed. So this is our application running and completed so far. So let's do a quick recap. Let's do a quick recap of what we've done. We used Terraform to provision the infrastructure in AWS cloud after we provisioned a workspace. We created a workspace, AWS_Pro. We used Ansible to install the Kubernetes software and tool in our master node and our worker nodes. When we did that, we went into Jenkins and our Jenkins server. We also have Docker server running there, and we pulled the image, the Nexus image, and the code quality analysis tool, which is SonarQube image. We pulled it, and we deployed both of them to run on our Docker server, so we can do a code quality analysis and push to our repository in Nexus. So when we're done with that, we wrote a pipeline, Jenkins pipeline script from end to end. I will paste the script. I'll paste the script in the GitHub repository for you to take a look at it and to also use it as you will. So this is the script from end to end, deploying this application from end to end. So you could simply just, in the real work environment, production environment, or taking test environment or dev environment, when we have this script written in this format and well written from beginning, end to end, from the source code manager, the Git, till we get to deploy in the Kubernetes master. Paste it at once, and your job is as good as automated. You can also configure triggers, build triggers to work from here. GitHub webhook, pull SCM, build periodically, and build after other projects are built. You can configure that to work such that once the code is committed in your source code manager, you are able to get this Jenkins triggered to do a build and publish to your space, whether it's the dev environment, whether it's a test UAT space, or it's a production space. Yes, I hope you have enjoyed this video. This is our application running. We've been able to access it. So I hope you have enjoyed this video. Please do like and subscribe for more. Thank you for sticking on.